For most people, electricity is not something they actively think about. It is part of the background structure of the home. Lights turn on, appliances run, devices charge. Heating and cooling systems respond, and daily routines continue without interruption. Because this process is continuous most of the time, power feels permanent, almost invisible. That impression of stability is often misleading. In practice, most homes are not built around energy independence. They are built around uninterrupted access to a centralized system. As long as that system functions normally, the home appears reliable. But what looks like resilience is often just continuity borrowed from the grid. The difference becomes visible only when the flow stops. A short outage rarely affects just one function. It spreads quickly across multiple layers of household life. Lighting disappears first, but the larger issue is usually elsewhere. Refrigeration, communication, climate control, powered medical equipment, internet access, garage entry systems, charging, and basic visibility during movement inside the house. The home does not lose one convenience, it loses a chain of connected functions at the same time. This is why residential power can feel stable right up to the point of failure. The system works as a single dependency, and most of its weak points remain hidden during normal use. When people begin to think about this problem, the first response is usually familiar. Reduce consumption, use flashlights, keep spare batteries, buy a fuel generator, install rooftop solar, or simply wait for service restoration. These are common attempts to create a margin of safety around the household. But each of these responses has limits. Reducing consumption does not solve loss of access. It only lowers routine demand. Flashlights and batteries help with visibility and small electronics, but they do not restore household power. Fuel generators can provide backup, but they introduce storage issues, maintenance requirements, noise, fuel dependency, and mechanical wear. Rooftop solar is often discussed as a long-term option, but in many cases, it comes with cost, installation, orientation, cleaning, permitting, and system complexity. So the problem is not just whether backup options exist, it is whether those options actually reduce When people begin to think about this problem, the first response is usually familiar. Reduce consumption, use flashlights, keep spare batteries, buy a fuel generator, install rooftop solar, or simply wait for service restoration. These are common attempts to create a margin of safety around the household. But each of these responses has limits. Reducing consumption does not solve loss of access. It only lowers routine demand. Flashlights and batteries help with visibility and small electronics, but they do not restore household power. Fuel generators can provide backup, but they introduce storage issues, maintenance requirements, noise, fuel dependency, and mechanical wear. Rooftop solar is often discussed as a long-term option, but in many cases, it comes with cost, installation, orientation, cleaning, permitting, and system complexity. So the problem is not just whether backup options exist, it is whether those options actually reduce dependency in a practical way for an ordinary household. This is the structural limitation many people miss. A home can appear electrically secure while relying on a system it does not control, cannot repair, and cannot stabilize during disruption. Most households are not managing power generation, they are managing the consequences of interruption. That distinction matters because it explains why the experience of reliability can be so fragile. The apparent stability comes from constant external support, not from internal resilience.
That is also why alternative energy formats continue to exist outside the standard choices most people think of first. Some are large-scale and professionally installed. Some are fuel-based. Some depend on weather patterns or specialized hardware. Others take the form of compact, self-assembled systems designed around a narrower purpose, not replacing an entire utility structure, but creating a smaller layer of continuity when centralized power becomes unreliable.
One example of this category is a digital guide built around a compact solar-based setup using focused light and a small parts list. It is presented not as a utility replacement in the industrial sense, but as a household format system meant to fit within limited space and basic material constraints. In that context, the product is not the main subject. It sits within a broader pattern, the existence of systems designed around continuity, simplicity, and partial independence rather than total infrastructure substitution. That broader pattern is the more important point. Residential electricity often feels stable because failure is infrequent enough to remain abstract. But the underlying arrangement is more fragile than it appears. Most homes are highly functional under normal conditions and quickly exposed under interrupted ones. What seems dependable is often only uninterrupted access to something external. And once that distinction becomes visible, household power stops looking like a fixed condition and starts looking more like a design assumption, one that only becomes noticeable when it breaks.